Hi everyone, today we're going to be looking at how to calculate mean, median and mode from a table of data. So I guess you could say it's our average maths lesson. See what I did there? Alright, so let's have a look at this table to begin with. So this table shows us some maths test results, and we're an IB school, so these are our IB scores that you get, 3, 4, 5, 6, 7. And then this column tells us how many students got that score. So 2 students got a score of 3, 8 students got a score of 4, 5 got a 5, and so on. And so I think it's helpful just to begin with to actually just write that out so we can visualize what that looks like in the raw data form. So if 2 students got a 3, that means there were 2 scores of 3, like that. 8 students got a 4, so we've got 8 4s, like that. And then 5 students got a 5, and you start to get a bit of a picture of what the raw data looks like. We won't go all the way. So it's just helpful to keep that in mind that as we're looking at this table, this is what it looked like in the raw form when we first got the data. But what we've done is we've put it into a table like this because making a table when we have lots of data is a really helpful way to do those calculations of mean, median and mode, particularly mean, rather than having to add up all of these individual bits of data. So we're going to look at a process today where we can calculate the mean from this table, and it means that it's not quite as accurate as what it would be doing it this way, but it's certainly much faster and efficient. And when we say it's not as accurate, it is still really accurate, just not quite as accurate as that one. There's a little bit of a trade-off, but for what we're doing at school, it's certainly accurate enough, and we're only talking, maybe a little bit of a decimal place. It's not like it's a completely different number or anything like that. All right, so like we said, this column here tells us how many students got a score of 3, how many students got a score of 4. And so another word for this column is frequency. This is the frequency of those scores. And you might sometimes hear this table referred to as a frequency table. And so what we're going to do is we're going to give this column another name. We're just going to label it with a little f, and that stands for frequency, because frequency is how often something happens. So how often did someone get a 3? Or there were 2 students that got a 3. How often did we get a 4? There were 8 students that got a 4. So that's a frequency. This column over here, we're going to label this with a little x, because this is our unique variable column. This is the variable that's changing in each situation. A bit like your independent variable in a science experiment, that's the thing that changes. And so we're going to label this with an x. Now the way that we're going to work out the mean from this table is we're going to create another column over here called xf. And if you remember back to algebra, when you have 2 letters right next to each other, it means that they're multiplied together. We're just a little bit lazy as mathematicians and we don't want to write the multiplied sign in there. So xf means x times f. And so for this first row, that would be 3 times 2, which equals 6. The next row would be 4 times 8, which is 32. And so on. You don't actually need to write out that first bit, so let's just write in the next one. 5 times 5 is 25, 6 times 9 is 54, and 7 times 2 is 14. And so now we've got these 3 columns, our unique variable, x, our frequency column, f, and this new column, xf. And to work out the mean, there's one more step we need to do. We need to add up all of the numbers in both of these columns. And you can see I'm using a little symbol here, which is a Greek symbol, and it means sum of. So this symbol is a Greek symbol, it means sum of, and remember sum is a maths word, which means to add. So it means we need to add all of these numbers together, and what do they add up to? So the sum of xf equals, and look what I prepared earlier, 131. So if we add all of these numbers together, we get 131. The sum of our frequency column is 26. If we add all of these numbers together, we get 26. So what is that number telling us about the students in our class? If the frequency of all of these scores is 26, what does that tell us? Maybe just pause the video for a minute and see if you can work it out. What it tells us is that there are 26 students in the class, because remember, if we were to write out all the scores like we did at the start in their raw form, we should have 26 different scores, which would mean there are 26 students in our class. So that's what this sum of the frequency column tells us. It tells us how many data values we have, in this case, how many students in our class. This column here, this sum here, is not quite as obvious to sort of see the relevance of it, and that's because we need to learn a formula first, and this is the formula here. So this little x here with a line over the top means, again, pun intended, means the mean. So this is the mean of x, or the average of x. That is what this formula is going to let us calculate. And you can see the way we do that is we put our sum of our xf column, this is a fraction line, so that means divided by the sum of our frequency column. So the sum of our fx divided by the sum of our frequency column. So if we just keep working across here, the sum of our xf is 131 over the sum of our frequency, which is 26, and if we do that, then we get an answer roughly 5.08. So a bit over 5. And so that's saying the mean test score, the average test score for this class was 5.08. And so that is how we can use a table of data to then work out the mean, rather than having to add up individual scores like that. Now there's a few other things we can read off this table as well. And I think let's just do the mode first, because the mode is usually nice and quick to sort out. So the mode, if you remember, is the most common data value. So in other words, which test score was the most common? Which test score did most students get, I guess? And so we look down our frequency column, and we can see here that 9 students got a 6, and that is more than any of the other scores. So because 9 students got a 6, then 6 is our mode, because that was the most common score. Now there's one last thing we can work out, and that is our median. And if you remember, again, last lesson we looked at mean, median, mode. Median is the middle data value when you have them all set out like this, from lowest to highest. So if we set all our data values out from lowest to highest, which number is our middle one? And that represents sort of the point where we have 50% of the data, 50% of the data, and so we want to know, like, where is our data sitting. So we could set it all out again like this. We could, write out all the scores, all 26, and then find the middle one, and that would be it. But we can also just do it by looking off our table. And there was that little formula from last lesson. I might just put a bit of paper over here now so we can have a bit more space to work out. There was that little formula we learnt last lesson, which says that n plus 1 over 2 equals our median data value. So n is how many data values you have in total. In this case it's 26, we have 26 students. So 26 plus 1 over 2 equals, and 26 plus 1 is 27, divided by 2 is 13.5. So remember, 13.5 is not our median. That is telling us that our median will be the 13th and a half data value. I know that sounds a bit weird to say it like that, but what it means is if we lined up all our data values from smallest to largest, our median would be in between the 13th and the 14th data value, 13th and a half. So, because if we split all our data again into those two groups, then we would have 13 in one group, 13 in the other group. That's our 26 data points. And in the middle here, we would have 13 and 14. That's our, if you number them, that would be number 13 and 14. And to get the median for this data group, because it's an even amount, we have to take the mean or the average of those two middle numbers. So we're looking for the 13th and 14th data value, and we find it by adding up the frequency, because this again is telling us this, isn't it? It's telling us all of these scores put in order, you know, our 2 3s followed by our 8 4s followed by our 5 5s. So 2 plus 8 is 10. So that means by the time we get to finish that cell, we've got up to our 10th data value, and then we've got another 5 lots of 5s, and so that's going to take us up to our 15th data value, which is past 13 and a half. Which means that our 13th and 14th data values must be in this 5 group. They were kids who got 5s. And so that's going to mean that our median is 5. Now we can check that the old-fashioned way, I guess, by actually looking at the raw data values. And so if we actually count along 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So these two 5s here, these are our middle numbers in all our data, because we've got 13 to there, and then from that 5 onwards we would have another 13 to get down to the bottom of our table. So that's our 13th and our 14th numbers, and if we were to average those, take the mean of those, well, it's just going to be 5 because they're both 5. And that's why our median finishes up as 5. Okay, let's have a look at another example, and this one involves a really large amount of data. So this is a farmer who has collected all the weights of his sheep and wants to find out the mean median mode of his flock. Now, because we're dealing with a different type of data now, we're dealing with continuous data, so that's data that has been measured, not counted. It's really difficult to put that into a table like our last one, because you would need to have, if I just write it over here, you would need to have, for example, let's say one of your sheep weighed 25.1 kilograms. You would need to have a whole row just for that 25.1, and then you would need to have a whole row for 25.2 and 25.3, and you can see that to go all the way from 25 up to 60 would be a huge sort of table of data. It would be meaningless, really. And depending on how accurate, you might even need to have other measurements in here, 25.11 and 25.12 and so on. So that would be a waste of everyone's time. So what we do when we have a large amount of data, and also data which is of a continuous nature, so something that's been measured, is that we put it into these groups or classes. And so we can see here we've got one group of data which has sheep which go from 25 kilograms up to, but not including, 30 kilograms. So remember, this little symbol here means less than 30, but not including 30, because otherwise it would have that little line underneath it. So 25 up to 30, but not including 30. And so again, think about all the numbers that go up to 30, but not including 30. We're going to get right up to like 29.9999, anything, and that can go on forever, those nines, but not actually getting to 30. Once it ticks over to 30.0, we move into the next box, 30 up to 35, but not including 35. So the next row would be up to 34.9999 and so on, but not 35. We get to 35, we tick over to the next box. So that's how the table is set up. And that's because it's continuous data. We need to have ranges to be able to put our data into. So when you're trying to decide, how many of these different groups do I need, you want to aim for between 5 and 10 groups. That's the sweet spot. And so you need to think about the overall spread of your data, the overall range of your data. And in this case, we're going from 25 up to 60. So that is a range of 35 kilograms. And so you're thinking, how can I split 35 into sort of 5 to 10 groups? And if we do it in fives, 35 divided by 5, we get 7. 2, 3, 4, 5, 6, 7. So we've got 7 groups. That's right in that window of 5 to 10 groups. So that's again in our sweet spot. If we make the groups too big, like imagine each group here was 20 kilograms, we'd probably only have 2 rows. And so we're going to end up with 2 frequency numbers which don't really tell us much about how the data is spread out. Because the groups are too big, we've just got like a big lump of sheep in this group, a big lump of sheep in that group. We can't really learn much about, the different weights of the sheep. If we make it too small, like we saw at the start, if we make our ranges too small, we end up with this scenario where we have really useless small groups which again don't tell us much about the data because they're so small that we can't really see the trends and the spread of the data. So you want to aim between 5 to 10 groups to split your data up into, and that comes back to thinking about the range. What is my lowest value, what is my highest value, and then how can I split that difference into 5 to 10 groups. And you'll get better at that the more you do it. So the process for working out the mean from this table is similar to what we did in the last example, but there's a slight difference as well because of these groups. So the first thing we need to do is to sum up our frequency column again, just like we did last time. We'll sum that up. So the sum of our frequency column, and I've done this for you already, so that is 72. If you add all of those numbers, you get 72. And then I should have called that frequency, shouldn't I? There's our frequency column. And if you remember last time, we then called our unique variable x, and we went x times f, and we got our xf column. So this is going to be our xf column again, but the trouble is this time, if we call this column x, what do we multiply 5 by? Do we multiply it by 25? Do we multiply it by 30? Do we multiply it by any number in between, or do we have to multiply it by all the numbers in between? It gets really confusing. So what we need is we need a number which represents this group. And then because that number represents it, we can go ahead and multiply it by our frequency and generate our xf column. So we're going to call this column here our x column. And what we're going to do to get our number which represents this group is we're going to pick the number that is right in the very middle of these two. So the number that's right in the very middle of 25 and 30, and that would be 27.5. So 27.5 is right in the middle, isn't it? It's 2.5 away from 25, it's 2.5 away from 30. And we're going to do that all the way down. So this one here will be 32.5, this will be 37.5, and so on. We'll do that all the way to the bottom. And now we have a number that we can multiply our frequency by. We've got our x number, and we call these numbers our midpoints because they're the middle point between each of these classes. So our midpoints. And we're going to multiply that midpoint by there. And you just use your calculators to do that. So if I go 27.5 by 5, we get 137.5. So can you go ahead and do the rest of these for me and then check it in the video in just a few seconds. Alright, how'd you go? So you can see I've gone across and multiplied each of these to get my XF number, 37.5 by 14 and so on. And now we've got our column filled up. But we need to do the sum of this column again. So we need to sum our FX column. And that comes to 2,990. And so now, just like in our previous example, we're going to reuse this formula, our mean formula, when we're dealing with group data. And so we're going to take our sum of the FX column, 2,990, and divide it by the sum of our frequency, which is 72. And if we do that, 2,990 divided by 72, and if we do that, 2,990 divided by 72 is 41.53 to 4 significant figures. And so that is our mean weight of the sheep on this farm, the average weight of the sheep on this farm. And so we've followed the similar process to what we did last time, but because we had these classes, we had to generate a midpoint number, something which represents that class, and then we can multiply across, add them up, and put them into the formula. When we come to find the mode and the median, it is similar, but again, the classes just add that little flavor of difference. So we don't have a single number as such that we're looking for the mode, but we're looking just to see which group, which class has the most sheep in it, which one is the most common as far as it's got the most number of sheep in it. So we look at our frequency numbers again. Which one has the highest frequency? It's this one here. That's got 16. So this class, we call this our modal class. And that's just like when we have a number which we say is the mode. We're just saying that this group has the most amount of sheep in it compared to all the other groups. So that's our modal class. Median is the same. We're not going to talk about a number being the median. We're going to talk about a class being the median. So what is our median class? And it's the same process as before. We start by looking at our overall frequency, the sum of our frequency. How many data values do we have? We have 72. So we're going to use that formula again to help us work out which number we're looking for, which data value we're looking for. So n plus 1, so that's 72 plus 1, which is 73 divided by 2, and that gives us the 36th and a half. 36th and a half data value, that's what we're looking for. So remember, if we were to line all of the sheep up according to their weights, we're looking for sheep number 36 and 37. And we're going to take the average or the mean of those two sheep because that gives us the 36th and a half data value. So we don't need to write it all out, we just need to add up our frequencies again until we find where our 36th and 37th sheep are. So 5 plus 12 is 17, 17 plus 14 is 31. So by the end of these three groups, we're up to 31. Sorry, that's not very clear, that text, is at 31. And if we're looking for our 36th and 37th sheep, well, they must be in our next group here because there's 16 sheep in that group. So the 36th and 37th sheep will be in that group, which means our median class will also be that 40 to 45 group, so 40 to less than 45 group. And that's how you work out mean, median, and mode from group data.